Hello, today we're gonna work on this problem called power of x and n, and let's see, what have we got? Of course we can just use the inbuilt function, which is return x to the power of n, and it will work, but that is not what this problem is trying to make us to do. So we're gonna solve some edge cases first. First of all, if n is 0, so we're gonna return 1, and if n is smaller than 0, it's gonna return 1 over my power of x minus 1. And after that, we're gonna have to really execute it. I've solved this problem before recording this YouTube, and we could do something like for I equals in range, and then just multiply it over and over and over, but it'll take too much time. So what we want to do is we want to make this as efficient as possible. So one way we can do is that we can make it into multiplying itself. So in other words, like doing a power of 2 when this is an even, and what happens if this is not even. And that way we can just make it into even and then use recursion to just make it into even. Either way, it will just be log O, big O of log n. So if n is this kind of odd number, we can just use x times my power x and minus 1 else. So this means this would be an even number, right? So actually I have wasted some time doing return my power x comma n over 2 times x my power x comma n over 2. So what is the problem with this approach? This approach would not be just log n, but it would be like an exponential value, because it will gonna have like 2 to the power of log n. So we don't want to do this. We want to do like my power x comma n over 2, and we just want to, so we don't call this twice every time we iterate this. And let's see this works. My power is not defined. Self dot n minus 1. I don't know why Leetcode is doing this to me. And let's see. It's the wrong answer. Input 2, output 4. Really? Oh, sorry. And it works. So that is it with my power, and we can do it really easy with recursion. There are some other ways we could solve this not using recursion. So one way we can think about is that we can use this as a binary numbers and use bit manipulation. In other words, we can do result equals 1 and while n is bigger than 0, we're gonna do how many steps this is gonna like take. 2 to the power of, so 1 means like power is 0 at first, and if digit equals n and 1, so we're gonna get the first digit of the binary number and then just multiply the result out of it, which is x to the power of 2, 0. So to do this, we actually have to make a helper function. So what it would be is that if digit is 1, we can just multiply the x value, or and we're gonna keep on adding this to some kind of stack, I would say. So we're gonna keep up with x to the power of 0, x to the power of something like that. So keep, let's say it's keep equals x, and we're just going to multiply the to this also, and after this we're just going to return the result. Oh, and then we actually forgot to push the n. And it works. Wrong answer. Output 4. So what happens to keep? Oh, we have to actually do this. Let's see if this works. Wrong answer, 64. We're gonna print out digit. and keep also, and the result also. And this will show you what we have done wrong. Okay. And now its digit is 0. Okay, I get that. And it's 2. So 10 is like 1 1 1 0. So digit is 0. It's because 10 is like 8 plus 2, right? So it should be 0 1 0 1. So it should be like result times get it. So this should not be like times x, but it should be keep times keep. And still don't know what. Huh. Okay. So this should be x, and this should be keep. Yeah, and this works. Let's see if this works. Okay, so for some people that don't understand what I'm doing, I'm basically doing the same thing, but we're using bit manipulation. So instead of saving everything in the stack, I'm not using recursion here, I'm using iterative. So this might be a little better, like memory wise. If you see here, it's using 13.8. I'm using 13. What's happening here? Yeah, so I'm actually saving 0.1 megabyte less memory. It should be more if the stack is really huge, because that's what recursions do. But as we saw today, there are a lot of ways to solve this problem. We can use bit manipulation, we can use recursion, we can use a lot of things. Okay, see you next time. Bye.